1. Introduction: the problem of volatility. Up until now, all the data we've used in our C programs, variables, arrays, structs, has been volatile. Volatile data means the data only exists in the computer's RAM, random access memory, while the program is running. As soon as the program finishes, crashes, or the computer is turned off, all that data is completely erased. Think about a text editor. If you type a 1,000-word report but forget to save, all that work is lost when you close the application. That's volatile data. 2. The solution: persistent data with files. To store data permanently, we use files. A file is a sequence of bytes stored on a non-volatile storage device, such as a hard disk drive, HDD, or solid-state drive, SSD. Persistent data means the data remains available even after the program stops executing and the computer shuts down. By using files, your C programs can achieve real-world functionality, saving game scores, storing user configurations and settings, logging error messages, managing large databases of customer or inventory records. 3. Files versus variables: the core difference. 4. Two types of files in C. In C, we generally categorize files into two types based on how the data is stored and interpreted. A. Text files, human-readable. Content: store data as a sequence of ASCII or Unicode characters. Reading: you can open and read a text file using a standard text editor, like Notepad or VS Code. Examples: configuration files, .cfg, log files, .log, or simple text documents, .txt. Drawback: storing the integer 123 takes 3 bytes, 1, 2, 3, plus maybe a new line character. B. Binary files, computer-readable. Content: store data exactly as it is represented in the computer's memory, as raw binary bytes. Reading: cannot be read directly with a text editor. The data will appear as garbage characters. Examples: executable programs, .exe, images, .jpg, or compressed data archives. Benefit: highly efficient. Storing the integer 123 takes only 4 bytes for a standard integer, regardless of how many digits it has, resulting in smaller files and faster read-write times. 5. File stream, the communication channel. When your C program needs to interact with a file, it doesn't access the file directly. It uses an abstraction called a file stream. A stream is a sequence of bytes flowing between a program and a device, in this case, a disk file. When you want to use a file, your program must establish a link to the file on the disk, opening the stream, operate on the stream, reading or writing data, close the link, closing the stream, which saves all changes and frees up resources. This stream is managed by a special type of pointer provided by the C standard library. 6. Conclusion and next steps. We now understand why files are essential. They provide persistence for data, allowing information to survive beyond the program's execution. In the next lesson, we will get practical and learn how to use the C standard library functions to create and destroy that vital link between our program and the file on the disk. Our next lesson is 8.2. Opening and closing files, using file ** pointers and the fopen, fclose functions.